In this video we are going to talk about the number system, that is how do we represent our modern numbers. We are normally aware of what our decimal number system is. For example, if we have a number 2453, we write this as 2 into 10 to the power 3 plus 4 into 10 to the power 2 plus 5 into 10 to the power 1 plus 3 into 10 to the power 0. So 10 is our radix. Okay, so our base or radix is equal to 10, but we could represent any number in any other base which is a positive integer greater than 1. So for example, if we have a base of 2, then we have what we call is a binary number system. Now you should always notice that whenever we have any base, we need that many symbols. Okay, so for example, if our number system is binary, we need two symbols because our base is 2, and those two symbols will represent the number 0 and number 1. Similarly, if we have our base as number 3, we need three symbols, 0, 1 and 2. If we have 4 as our base, we need four symbols, which is 0, 1, 2 and 3. If we have 8 as base, which is the octal number system, then we need numbers 0 to 7. So 0 to 7 will represent the numbers 0 to 7, and 8 will be represented by 1, 0, because 1, 0 can be written as 1 into 8 to the power 1 plus 0 into 8 to the power 0. So you can see that if I write 1, 0 here, then this is actually equal to 2, because this is 1 into 2 to the power 1 plus 0 into 2 to the power 0. If I write 1, 0 here, this is equal to 3, which is 1 into 3 to the power 1 plus 0 into 3 to the power 0, right? So in any number system, for example, if I write 1, 0 here, this will be equal to 16. If I write 1, 0 here, this is equal to number 10, right? If I write 1, 0 here, this will be equal to number 4. So if our base is r, 1, 0 is equal to that number r, correct? So if I have any base which is a positive number r, a positive integer r which is greater than 1, then you need r symbols, 0 which represents number 0 to r minus 1. So there are going to be total of r symbols. Okay, and 1, 0 will be equal to the number r itself, right? So once we know this, now let us talk about some basic rules of addition. So we will start with something what we do in normal base 10, and we will, whatever we do in base 10, we have to do the same thing in any other base. Okay, okay, let us for example consider adding number 3902 to 9019. I'm just making up numbers here, okay, and I'm adding it in base 10. So we know that 9 plus 2 is 11. So if we divide 11 by 10, what is the remainder? It is going to be 1. So we put 1 here. And what is the quotient? It is also 1, because 10 times 1 is 1. So we add 1 here, or 1 times 10 here. So this becomes 1 plus 1 is 2. This is 9 plus 0 is 9. Now again, 9 plus 3 is 12. So you divide 12 by 10, you get the remainder as 2. And what is the quotient, it is again 1. So you get 1 here, and this is how you add numbers. So let us see how to add numbers in different bases. So we will see this problem here. For example, the first problem is add 2, 3, 2, 4, 1. So let us do the first problem. It says add 2, 3, 2, 4, 1, 4, 0, 3, 2 and 3, 0, 0, 4, 2, 1. Okay, so remember that we have to add it in base 5. So 1 plus 2 becomes 3 and 3 plus 1 becomes 4. Now 4 plus 3 is 7 and 7 plus 2 is 9, right? So now 9 is greater than 5. How many symbols you can have here? You can have numbers 0 to 4, right? So 4 plus 3 is 7, 7 plus 2 is 9. So now you divide 9 by 5. What is the remainder? You get 4. And how many times has 5 gone by? That is how, what is the quotient if you divide 9 by 5? It is going to be 1. You put 1 over here, right? Now 3, 2 plus 1 is 3, 3 plus 4 is 7, right? Now again 7 is greater than 5, so you divide 7 by 5. What is the remainder? You get remainder as 2. Quotient is again 1. Now you have 3 plus 1 is 4, 4 plus 4 is 8. If you divide 8 by 5, you have 3 as the remainder. Quotient is still 1. 2 plus 1 is 3 and 3. So this is what your addition will be in the base of 5. Now let us see second problem. Over here the base is going to be 9. So base is 9 and we have to add 3, 0, 3, 4, 7, 8, 1, 5, 0, 7, 3, 2, 2, 6, 4, 3, 0, 5, right? What are the symbols you can have? You can have numbers 0 to 8. So 8 plus 2 is 10. 10 plus 5 is 15, right? 15 is greater than 9. So if you divide 15 by 9, what is the remainder? Remainder is going to be 6. And what is the quotient? Quotient is going to be 1. So you have 7 plus 1 is 8. 8 plus 3 is 11. If you divide 11 by 9, you get the remainder as 2. Quotient as 1. 4 plus 1 is 5. 5 plus 7 is 12. 12 plus 3 is 15. Again you get remainder as 6. Quotient as 1. 3 plus 1 is 4. 4 plus 4 is 8, which is less than 9. Then you have 5 plus 6 is 11. So again you have a remainder of 2. Quotient of 1. 3 plus 1 is 4. 4 plus 1 is 5. 5 plus 2 is 7. So this is problem number 2, how to add in the base 9. Now let us look at subtraction. We have to subtract from 3, 6, 7, 3, 1, 2, 4. And we have to subtract 1, 7, 3, 2, 7, 6, 5. 1, 7, 3, 2, 7, 6, 5. Okay, we have to subtract this. And what is the base? Base is equal to 8. Right? Now we have to simply do the opposite. So Is 4 less than 5? Yes. So we need to carry over. Now once you carry over, this becomes 1 4, right? This becomes 1 4, not 14. Okay, remember this is not 14, this is 1 4, which is 8 times 1 plus 4 is 12. So 12 minus 5, what is 12 minus 5? 12 minus 5 is actually equal to 7. Okay, you have to be very careful. This is not 14, this is 14 in base 12 is actually equal to 1 into 8 plus 4, which is 12. So you have to remember that 1 4 is, that is why I am calling it 1 4, I am not calling it 14. Symbol 1 4 is equal to 12, and 12 minus 5 is 7, right? Now because we have carried over here, so this becomes 1. Now 1 is again larger than smaller than 6, so we carry over from here, so this becomes 0 and this becomes 1 1. Okay, now what is 1 1? This is 8 plus 1 is 9. 9 minus 6 is 3, so you will get 3 here. Okay, now this is 0, again less than 7, so you make it 2 here, and this is 1 0. 1 0 is 8. 8 minus 7 is equal to 1. 2 minus 2 is equal to 0. 7 minus 3 is equal to 4. Now this is 1 6, and this becomes 2 over here. Now what is 1 6? This is 8 plus 6 is 14, so 14 minus 7 is 7, and 2 minus 1 is 1, right? So this is how you subtract when you are using a different base. Okay, always remember that 1 4 is not 14 but some different number in different base. Okay, so you have to be very careful while subtracting and adding. So let us do problem number 4. From 3TE756 take 2E46T2 in duodenary scale. Okay, so what they are saying is that base is equal to 12. Okay, and because this is a old book, what they are doing is they are saying that T is 10, E is equal to 11. Okay, so this is what they are using in this case, that T is equal to 10 and E is equal to 11. We will say A is equal to 10 and B is equal to 11. Okay, so we will use the modern notation because A is 10 and B is 11. This is what is used in the hexadecimal number system. So our first number is 3AB756. Okay, 3AB756, and we have to subtract 2B46A2. Now 6 minus 2 is simple, this is 4. Now this is 5 and this is 10, right? So we need to carry over, so this becomes 6 and this becomes 1 5. 12 plus 5 is 17. Now 17 minus 10, 17 minus 10 is equal to 7. Now this is 6 minus 6, which is 0. Again this is B. B is for 11. 11 minus 4 is 7. This is 10 and this is 11, so you have to carry over. This becomes 2 and this becomes 1A, right? So this is 12 plus 10 is 22. 22 minus 11 is 11, so you get B here, and this is 2 minus 2, which is 0, so you get your answer as 0B7074. and we are done.